Alright, so here is our first video in the lesson, Analyzing Complicated Geometric Shapes. In this lesson, we're going to be kind of concluding all of the different formulas about geometry we've learned with our 2D shapes. And we're going to be solving some problems that requires lots of critical mathematical thinking and sometimes requires a lot of kind of like splitting apart into smaller steps. So before we get into any problems, I just want to kind of review some of the models we've seen. So here's our first geometric model, and it's a quite simple one. We see a rectangle ABDC, and the reason why it's not ABCD is because the C isn't here. All right, so ABDC. That's a rectangle, and we see that there's a shaded area, and that is a triangle. And the triangle takes up an entire side, and its other vertex reaches all the way to the other side. Now we know that triangles are one half of the corresponding rectangles. That's why when we find the area of a triangle, it's 1/2 base times height, right? There's always that 1/2, meaning that this is always going to be 1/2. So this is the half model, very basic, should be able to recognize right away. And knowing this, we can also think about this unshaded part. So these two unshaded parts added together is also half of this rectangle. So that's just some sort of left to right, right to left thinking right there. Now let's look at our next model. And it is and it's basically we see a rectangle and it's split into 4 sections, right? And it's all triangles. And this is O. O is a random point anywhere in here. So you might think that this is, well, it's not organized, but really there is a pattern to it. So actually, S1 plus S3 is equal to S2 plus S4. So the opposite triangles, the opposite areas added together equal each other. So that's interesting. And the value that they equal is 1/2 of the area of ABDC. All right, so this plus this is equal to 1/2 of the entire rectangle. This plus this is also equal to the entire half of the rectangle. So this is something that we'll be using. Now let's look at, well, these two triangles right here. All right, let's first look at this one. So this is, it kind of looks like the tip of the mouth tip of a bird actually. So this is the face, but this is the beak. Now this is two triangles on top of each other. And a lot of the times we're asked to find a relationship between the areas of these two triangles or something else. But this is talking about ratios, especially ratios. So as you can see, AE, let's see, kind of looks like about the same size as EC, and AD and DB, let's say this is 3 to 2. Anyway, so using these ratios, we can find out the fraction, the relationship between these two areas. And as we go to the problems, you're going to get what I'm talking about more. And this is just another form of that. It's just that this triangle, you see it's kind of squished, but still same idea. All right, so as you can see, this is a trapezoid, and this is kind of the more complicated ones because it's a the quadrilateral right here. So this is split into 4 sections, and again, this is a triangle, and you can kind of correspond that with what we see up here. And we have S1, S2, S3, and S4. Now, what's the rule here? Well, we need to know that S2 is equal to S4. We also need to know that S1 times S3 is equal to S2 times S4. So that is all of the models we're going to learn today. And if you want to hear some of the proofs, you can go back into our YouTube channel because we have some other lessons that are based each on one of these models. So I'm going to put the links to those in the description down below. So good luck and see you in our next video.